Again, good afternoon. I'm Seth McElvaney. I would like to welcome you to the concurrent session on microbiology. In this session, we'll have 3 presenters sharing their research while in the START program. So we will begin with Safana Algutaini. Again, please, make sure that your mics are muted. Use the raise hand feature if you would like to ask questions when the presenter is finished, or you can also write questions in the chat. Again, due to time limitations, we may not get to every question, but we do encourage questions. So, Safani, I'll ask you to start your session.
Okay. Let me just share my screen. Shall I start?
Please start.
Okay, so I am part of the team Antibiotic Resistance, and my name is Safana Algutaini. So today I will talk about what my research is. So a brief background about the problem. Antibiotics are used to treat bacterial infections, and some bacteria are naturally resistant to some antibiotics. And many bacteria species are becoming resistant to all antibiotics. So, my hypothesis is that the abundance of antibiotic resistant bacteria will change over time due to changes in environmental conditions. So, let me give you a brief introduction about my site. So, historical data about the site I'm collecting my sample from is that it is weighted. And as stated by a professional worker at Wakedack Community College, the property was weighted in not farmland. There was some pasturous area as you move towards the south and towards it, what is now the 4401 development. But I think that what we bought was mostly weighted. So the site is between Wakedack North Campus and the buildings. So I usually see some G's and humans are seen there, and sometimes I see birds. As you can see here, that's my site, and that's how the water looks, and that's some G's that I see over there. So my experimental plan is pretty simple. We just collect a water sample from the site, and then we inoculate that sample on 4 different Luria air plates, and then we let it grow at room temperature for a week. And then we count that resulting colonies, and we identify the colonies' margin, size, elevation, shape, obesity, consistency, and color under a microscope. As you can see here is my data. So my y-axis is going to be the colony forming units with 100 microliters, and my x-axis will be the assembling date. So my plate is going to be control is methersin, ciprofloxacin, meropenem, megcolistin. So as you can see here, it's not constant and it's fluctuating. And the reason for that is for the temperature conditions and the environmental conditions that change. So usually I go there when I collect my sample and it's cloudy and the weather temperature is kind of like the weather like movement is slow, and whenever it's the weather is sunny, the weather is rapid and a little slow. So that's my data, and that's how when I collect my colonies, how they look like. My conclusion is that data supported my hypothesis, and as you can see that my hypothesis was supported because the abundance of antibiotic resistance bacteria changes over time due to changes in environmental conditions. Species are becoming resistant to all antibiotics. And at the end, I want just to acknowledge all that thing that I have done. Thanks to our manager, Dr. Nunez, and thanks to Wakedack Community College, and thanks to START program for giving us this awesome opportunity. And thanks to the Bank of America Foundation, and thanks to Marie Planetarium. Thanks for watching.
Okay, thank you, Safana. Does anybody have any questions for Safana about her research?
Yeah, Seth, I don't see any questions in the chat, but I do have one question for Safana. So, do you have plans to continue with your research in near future? Hello, Safana, can you hear me?
Safana, we have a question for you.
I'm sorry, I was muted.
Oh, okay, no problem.
So I'm just was answering your question. So we are not almost done because we have already collected all this data, but then we're gonna isolate that bacteria and know what kind is that bacteria is. So for example, my bacteria, it turns out that one of the kind of the bacteria that I collected is a gram, but it's a gram negative. And we see that under a microscope, and we find it through doing that through substance that we like put that bacteria into substance to discover what kind of it.
Okay, yeah, thank you. Any other questions from the audience?
Okay. Do we have other questions?
Yeah, I do see somebody raised their hand. I'm not able to see who it is.
Dia Patel.
Hi, Safana. That was a really great presentation. It was so informative. I was just kind of confused on your location. Where exactly was that? And can you like explain like more about that?
Yeah, so the location is, if you know the North Campus, Building H. So after Building H, there's like a place over there, a small, you cannot say a small bond, but it is a bond over there between buildings that is in that area. So that's my side. And what was your question? The other question, please?
I think that was just it. I was just really confused on like where it was located, but it was really good.
Awesome, thank you.
Thank you for sharing.
Mm-hmm.
Okay, and thank you all for the questions, and thank you for the presentation, Safana.
Of course.
All right. Next up, we have Anjali Chandrasekhar, who has a talk ready for us.
Thank you, Mr. McElhaney. I'm just going to present my screen. Can you see that?
Yes, we can see that. You might want to get a little bit closer to the microphone as we're getting some background noise too.
Okay, cool. So this is my presentation on antibiotic resistance in environmental bacteria. So the objective of this study was more of a correlational study, a descriptive study than an experimental study. So it didn't have a hypothesis, but I wanted to find a correlation between the percentages of antibiotic-resistant pathogenic bacteria in clinical settings with the presence of antibiotic-resistant non-pathogenic bacteria in local water bodies. And so in order to do this, I analyzed two sets of data. The first set of data was from the Centers for Disease Control, and basically they gathered laboratory data from clinical settings all across North Carolina pertaining to healthcare-associated bacterial infections. And basically what those are bacterial infections that happen when people come into the hospital for something else and then contract these infections due to poorly maintained catheters or other unhygienic circumstances. And I also compared this data with data collected by other START interns, including Safana, and basically I looked at the number of colonies that were cultivated in an antibiotic-laced Triptychilla or McConkey agar. And the idea behind this was that if the if the bacteria grew in such an agar, then it was resistant to the antibiotic. And so here I have a couple of the antibiotics analyzed by the START interns. We have ciprofloxacin, which is a fluoroquinolone, colistin, which is used as a last resort antibiotic along with ciprofloxacin, meropenem, and azithromycin, both of which aren't last resort antibiotics. They're actually used more commonly. And for this study, I was able to get data for fluoroquinolones, such as ciprofloxacin, and carbapenem, such as meropenem, which is reflected in the next slide. And so this is just a slide which contains all the CDC data that I compared to the START interns data. And so I was able to find seven different types of bacteria that were resistant to either fluoroquinolones or carbapenems. And on the y-axis here, we have a percent resistance, which is basically the number of bacteria that were deemed resistant by laboratories all across the United States, specifically North Carolina, over the total number of bacteria that were analyzed by all these laboratories. And here I have a little bit more about the estimated percent antibiotic resistance from the CDC data. And basically, the values that I compared were a little dated because the CDC only had data up until 2018 due to the COVID-19 pandemic. And I anticipate after a little research that the COVID-19 pandemic probably increased antibiotic resistance because according to a VCU health system study, a lack of resources because of the COVID-19 pandemic may have caused antimicrobial stewardship programs to become lax, which may increase antibiotic resistance. So there isn't much data to support this as of yet. And another harrowing study from Albert Einstein College of Medicine basically found that 70% of all patients in a New York hospital that were getting treatment for COVID got antibiotics, but only 3.6% experienced healthcare-associated infections. And this points to antibiotic overprescription, which points to increased antibiotic resistance. However, antibiotic resistance and bacterial populations can decrease. I saw this when analyzing historical data over around 7 years in North Carolina. And according to a Finnish study, reducing prescription of macrolide antibiotics by half reduced the percent of erythromycin-resistant Staphylococcus aureus by half as well. And here I have just a summary of all the data that I analyzed. So here I have an average of the carbapenem resistance in HAI-causing bacteria, which is basically an average of the percentages of carbapenem resistance within the 4 carbapenem-resistant species out of 7 in the CDC data. I also did the same thing for the fluoroquinolone resistance with the 3 species from the CDC data, and I came up with these percentages. And then I compared the average antibiotic resistance to the average resistance in environmental bacteria. And basically what I found was that there was no positive correlation between antibiotic resistance in hospital settings and in environmental settings, because as you can see, as carbapenem resistance as antibiotic resistance in HAI-causing bacteria increases, the resistance in environmental bacteria decreases, which doesn't make much sense, but it may be due to other factors in the environment, including the amount of prescription of antibiotics, because as I said before, fluoroquinolone is, ciprofloxacin is a fluoroquinolone, which is basically less prescribed than carbapenems, which may contribute to its lower environmental resistance. Obviously, there were a lot of limitations for this study, as I have indicated on this slide, which means that I just have preliminary data from it, but still it provided a good snapshot for antibiotic resistance in environments in North Carolina and the Triangle area, and it gave me a lot of ideas for future studies. Before I end, I'd like to thank a bunch of people for helping me throughout this project. My mentors, Dr. Brian Nunez and Dr. Luke Dunyer. A bunch of START interns, Safana, Nathalie, Diana, Dia, and Caitlin for sharing their data with me. Ms. Sarah Horstman and Dr. Swanik and the START leadership team, Mr. Seth McElvaney and Dr. Malvi Balachandra for monitoring this presentation, and Bank of America and other sponsors of the START Symposium for their generous support. Thank you.
Okay, do we have any questions for Anjali? And thank you, Anjali, for thanking me. I was not expecting that. I'm blushing.
Thank you for moderating this presentation. Are there any questions?
Okay, so we have a lot of excellence and great jobs, a lot of compliments. We have someone typing. And saying wonderful presentation. Okay. All right, so if there are no questions, we'll move on to the next presenter, our third and last for the session, and that is Nathalie Seferovic, and she's also presenting on antibiotic resistance.
Give me one moment.
Oh, certainly. And Anjali, you can stop sharing, please. Thank you.
Okay, let me just share my screen.
All right, take it away, Natalie.
Hi, my name is Nathalie Seferovic, and I have been working with Dr. Nunez. I'm going to be talking to you about antibiotic resistance in Dogwood Hill Pond in 2021. The goal of this research is to collect data on the prevalence of antibiotic-resistant bacteria at Dogwood Hill Pond and record any patterns based on ecological information at the time of sampling. My prediction was that increased rainfall before the time of collection will cause an increase in the prevalence of antibiotic-resistant bacteria. A little bit of background on the Dogwood Hill Pond site is that it's located north of Raleigh in Granville County, very close to the Wake County line. It's a once rural but quickly developing area, as a lot of the surrounding Raleigh area is. There was actually trees being taken down for new development as I was sampling, which you can kind of see in the picture to the right. Historically, this area is surrounded by tobacco and cow farming. My experimental plan was that once a week in March, I collected a pond water sample that I then used to inoculate plates with commonly used antibiotics. Environmental data, such as air and water temperature, as well as weather, was recorded in order to observe patterns of growth based on conditions at the time of sampling. After a week of growth, I counted the number of colonies and recorded bacterial colony variation on each plate. Some observable patterns and predictions I was able to record were that rainfall does seem to correlate with an increase in the number of antibiotic-resistant bacteria present. As the water warmed in the spring, an increase in antibiotic-resistant bacteria is also seen. I predict that antibiotic-resistant bacteria present in Dogwood Hill Pond is related to the area's history of farming. There are just a couple of acknowledgements, and I just wanted to say thank you for your time and support as well.
All right, thank you very much, Nathalie. Does anybody have any questions?
Hey, Nathalie, I have a question. This is Caitlin. In what you found from your research, was there a specific antibiotic resistance that you found to be more prevalent? Like, I think from what I can remember, like Cipro is often used on farms and with vet animals. Did you find like more resistance to ciprofloxacin? Did you find it kind of equal across the board?
So that's a great question. I'm kind of looking at my data now. So not necessarily is the short answer. It really, like the data definitely fluctuated as time went on. And ciprofloxacin in particular, I wouldn't say was necessarily more, there wasn't more prevalence in that plate. But however, it was on the higher end. I'd like to do more research on what antibiotics are used in farming and how that all works. So those are really good questions that I want to do some more research on. This has kind of sparked that in me.
Awesome. Thank you.
Yeah, thank you.
Okay, very nice. Do we have other questions? Actually, I have a question. I was wondering about, you're saying there was an increase in the number of antibiotic-resistant bacteria. Did you notice an increase in just bacteria as a whole, or because you're putting in the antibiotics, were you not able to study that?
I hope I understand what you're asking. So do you mean which plates grew more, or do you mean if there was an overall increase?
Right. Was there, like, after rainfall, did you see an overall increase in just bacteria in general?
Yes, I did. That was really interesting because pretty much all of the plates with the different antibiotics, when it was really dry, there was a lot of rainfall during the time. It was actually really, really wet during a lot of the time I was sampling. And there was one particular date that was quite dry compared to the rest. And you'll see it tends to go up as, like, depending on how close it was to the last rainfall. And all of the plates seem to go up quite a bit.
All right, thank you. Thank you.
Yeah, thank you.
Satisfied my curiosity there. Other questions? It has been very nice. Thank you all for joining us. Thank you for coming to this session. And we have a link in the chat for our next sessions. So again, thank you all for joining us. Have a great rest of your day.
Thank you, Seth. Yeah.
Thanks, Seth, for moderating.
Oh, you're very welcome.
Next one is at 3:35, the final session, the closing session. Yeah.
Okay.